So we are in exercise 13, shoulder oscillation in the inertial unit, which essentially talks about the error and what's the nature of the error that arises when we have not properly initialized our inertial unit in the robot. And we are in item number 3, which has an object of providing a simulation of the trajectory of R2 initialized at a point, this point R01, and R is the radius of the Earth. So he will be initialized here, and we want the inertial unit to feel as it was here, and we are going to see what happens when in this case. So that's the simulation. Here we have the function that evaluates that updates the system, and here are some constants and the initial state. We are we were 1 point above, 1 unit above in the z direction from R1 to R2. So here is our loop of iteration, which is using a Runge-Kutta integration method, and we are plotting the robot position for every 10 points to make simulation quicker. We have also decreased the radius of the Earth to 10 because the oscillation frequency depends on it. So if we put the actual value of 6,378, I think, kilometers, we would have it would take a longer to run the simulation. So I'm starting right now, and this is what happens. This is what happens inside the inertial unit to sense as it would have if he were in this position, the 0 position, R1 here. So what happens here is that the inertial unit is not actually feeling this G vector right here of R1. Is feeling the deviated value of G. The G here has a component in the Z direction and a component in this X, and its component in the X direction was slightly diminished by a factor of 1 minus cosine of theta. So we are here, essentially we have the inertial unit is compensating these differences by creating a vector in this direction to compensate the modification here in Z direction, and another one in this direction to compensate this vector. So that's why the inertial unit moves by starting in R2. He goes downward and to the right in a sinusoidal movement. Also, if we change the initialization point to a closer point to the R1 position, if we diminish the error here, what we would see is a smaller amplitude of this shoulder oscillation. So the amplitude is proportional to how far we are from the actual initialization point. So we can diminish the effect by making a more precise initialization, but on the other hand, we cannot change the frequency of the shoulder oscillation, since the frequency change it's actually proportional to a ratio of R, the square root of R over G. The radius of the Earth is fixed, and G is also fixed around the point we are here in the Earth, unless we go to our space or we change make a significant amount of variation here. We would see the frequency around we would see the period around 84 minutes. So by knowing this, we can handle better the shoulder oscillation problem. For example, if we create a filter, a digital filter that suppress this frequency here, we can diminish our error, as of course by making a proper initialization by making the robot in his actual position.